Clover offers powerful semi-integration tools to customize your precise merchant experience. You get your own point of sale with the ability to take PCI-compliant dip, swipe, and tap payments. But with great power comes, well, in this case, extra vigilance and the necessity to account for all the unhappy paths that can occur during the transaction flow. So, if you've taken a look through our semi-integration guides, or spoken to a Fiserv representative, and you think the semi-integration path is the right one for your solution, then let's take a deeper dive into the details. We'll walk through what might go wrong in a standard setup, how you can collect information from all the moving parts in your semi-integration, and what options you have to get back on track when something goes awry. You'll also find more information on these topics in our Remote Pay SDK Best Practices documentation. Be sure to check that out along with our example code on GitHub. Customers wander off the happy path all the time, and payment systems in live environments need to work under all sorts of conditions, in the elements, with poor Wi-Fi, after a power outage. Consider the following cases. A customer doesn't notice the signature screen and leaves before the payment is completed. The point-of-sale system or a Clover app that it relies on crashes. A Flex was off its charging port for too long, and its battery runs out. A thunderstorm takes down the merchant's Wi-Fi, or a fritzing USB cable finally gives out. A robust payment system anticipates worst cases, and not as good as best cases, and steers transactions back on course. How many of these examples are applicable to your system? Jot some of your worst cases down, and let's build out a disaster plan for them. One of these scenarios occurs, how do you proceed? Before you can do anything, you'll need to have an idea about what state everything's in. It all boils down to good communication. It's good practice, then, for the POS to keep tabs on the Clover device. Retrieve device status allows you to ping the device to do just that. If it comes back as idle, it's not doing anything in particular, and is ready to take payments when you are. If it's busy, it might currently be processing a payment. Waiting on customer indicates actions like tip selection or signature entry. And if the device is waiting for POS, it thinks your POS needs to take action on something, like accept or reject a payment in response to a challenge. Device states offer a general view of what the device is up to, but they still encompass multiple activities. For a detailed view of the transaction's current stage, you can follow along with onDeviceActivityStart and onDeviceActivityEnd. It can be good practice to let the merchant follow along too. You can use onDeviceActivityStart to surface activity information as you go. For example, when the customer reaches the tipping screen, onDeviceActivityStart will return the event state. In this case, add tip. A more detailed message, customer is tipping, and any input options this screen has, such as being able to cancel out of the screen. In this way, you can learn what you're waiting on customer for, and scope out whether you can exit out of the current process if need be. So far, this assumes you can reach the device. But what if bad weather takes out the merchant's Wi-Fi, or a USB cable comes unplugged? There's not much the POS itself can do to re-establish connection, but monitoring connection status can allow the POS to alert the merchant when connection is lost. On-device connected and on-device disconnected occur when connection events do. A re-established connection also initiates on-device ready. Use these methods to stay apprised of the connection state. What's your first order of business after recovering your connection? You're probably concerned with how your transactions are doing. If you are waiting for a transaction to complete when you disconnected, you'll want to check back in on it. To do that, you need to have external IDs on your payments. This will be a persistent ID to track the transaction's progress, even if the Clover payment ID never returned. After generating a unique external ID for the transaction, you should therefore save it immediately. If something happens to the payment response, the external ID will act as a record of the attempt. You can then use this external payment ID to query the Retrieve Payment API, our next tool for discovering status. The Retrieve Payment API returns the payment status plus the whole payment object if it finds it. This makes it a powerfully useful tool to check that the previous payment has completed before sending a new transaction request, determine where payments are before taking drastic measures, such as using reset device, and check in on a payment in case you want to implement a timeout. In case the POS experiences severe connection difficulties or never receives a retrieve payment response, the REST API is available as a backup. The Get Payments endpoint provides a filter for external ID to easily check up on a payment, as long as you understand the REST API's limitations. These API calls check Clover servers rather than checking locally on the device, so any offline payments will not be registered until the device has had a chance to sync. You also won't be able to query information on a payment that's still processing. If the device isn't idle, you may not receive accurate information about the payment. Note that REST API usage requires corresponding app permissions and a web or APK component to retrieve an access token, so it may not be useful for every semi-int solution. With all these tools to collect data on the system status, you have a wealth of information. You should know the status of the device, the connection, and the payment. How do you use this information to your best advantage? How do you proceed when part of the system goes haywire? Some routes back to the happy path are straightforward. We build a way forward right into Retrieve Device Status Request. If the device's state doesn't seem right, setting Send Last Message on the request can be particularly useful. A lost connection or a POS crash can result in drop messages. By resending the last message, you can pick right back up, as long as the last message was a challenge, not a final response. If the transaction completed, the device won't resend the sale response. But if your POS missed the memo that it needs to make a decision on a challenge, retrieving the last sent message can lead to a clean recovery. On the opposite end of the scale, some routes back to the happy path are largely out of the POS's control. If the connection is lost entirely, with no luck reconnecting, the POS's best bet is to call for help. If a USB cable was unintentionally unplugged or a flex device ran out of battery, outside intervention is required. The POS can alert the merchant to get things back up and running. Merchant intervention might also be required for payments. Maybe a payment is taking suspiciously long. The customer might have walked out, or maybe they're just having a long chat with the cashier. In either case, it's good practice to surface the current activity's input options. If the payment really is no longer desired, the merchant can easily cancel out. The POS can also take the payment into its own hands. If adding a timeout is right for your solution, your POS can automatically cancel out of the payment itself after a certain amount of time has passed. You can take the available input options, including cancel, from onDeviceActivityStart. If cancel is a valid option, you can then pass that in through Clover Connector's invoke input option method. Note that you may have to walk back through several activities to fully cancel out of the payment, so keep checking whether the activity you're on has a cancel option. If the system is recovering from a crash, you can check on the status of any previously in-flight payments. If a payment didn't manage to go through before the crash, you can decide what flow makes the most sense for your POS. One option at this point is to surface the decision to the merchant. If Clover has no record of the payment or has voided the payment, the merchant can choose to reattempt the transaction request. Then again, the customer may have given up or moved on by this point. And if all else fails attempting to get back to a sane state, and you need a clean slate no matter what else is wiped away, Reset Device is a last-ditch option to get back to an idle state so you can start moving forward again. Before using, make sure you know the status of any pending payments, and recheck their status when you come back. Reset device may void those payments. This option is meant for exceptional recovery scenarios and is not meant to be part of an integration's normal flow. If you find that your POS is calling reset device frequently, something may be wrong. Ultimately, taking transactions is a complex process that involves moving parts and uncertainty in the form of customers and cashiers. We've walked through some of the more common unhappy paths and explored how to get back to the main thoroughfare. In review, on this cheat sheet, you can see some of the various possible scenarios and what symptoms you can identify from your POS. Every developer will have different use cases and requirements, so we can't prescribe exact solutions for each scenario, but we can arm you with the tools to build your infrastructure and point out the pitfalls. Beyond this video, our docs and sample projects are linked below. We also have a community forum for public help at community.clover.com and can answer more sensitive questions at dev@clover.com, semi-integrations@clover.com, and @marketbusiness@clover.com. We look forward to seeing what you build.